maybe we should start just, oh, yes. Do we want to talk about the questions that have been asked thus far? And I had forwarded Richard's to everybody today that Michael had sent out. And then there was Dorothy's on previously. So I don't know, were there any follow-ups that any of you guys follow up things you wanted to talk about? Take a minute to look at what those things were.
Well, I guess in response to some of Richard's things about roof.
Yeah.
I was thinking that it might behoove us to take samples of all the separate roofs to see, first of all, if any of them are restorable, and second, to know exactly what is underneath them as far as insulation or how bad they are, because they can tell by taking core samples. Because I'm thinking that at least the 2002 sections should be able to be restored as opposed to complete tear off and replacement. And there are very likely some other roofs at the high school that could be possibly restored, which would lower the cost as opposed to, putting new roofs on.
I remember that Craig Carter said when we were over at the high school, I thought I remembered him saying that the roof over the modulars was still under warranty. Do you recall that?
Yes, that one's not very old. It's a different kind of roof as opposed to the built-up roofs that are on the rest of the building. I know the gym roof is not restorable. I know that for a fact, but the rest of them, I don't know. We had them restored the last time when I was there. And my understanding is that you can keep restoring roofs as long as you don't wait too long. But I'm not a roof expert, so I'm not positive about that, but it'd be worth looking into for sure.
What do you think, Mike? What is your?
Well, my understanding is typically they will allow 2 layers. After that, there becomes a weight issue potentially. And that's usually when we see a tear off. And that's kind of on a built up roof. On a single ply membrane, I've never put a new single ply over an old single ply. So that'd be, I've never seen that.
No, I wouldn't do that anyway. Yeah.
And usually the issue is the insulation. I mean, the roof is a great place to gain some R value if you can get to the insulation. I know it's very expensive and roofing is becoming more expensive. But if you're at a point where you got to remove it to put down, R30 or R40 insulation is a huge energy savings if you can do it.
I know they had talked about, Craig Carter had told me about, he had someone come out and look at the gym roof specifically because it does need a tear off.
Yeah.
And he said it would impact the parapet walls because the insulation would have to be so high that they'd have to raise the parapet walls in order to do it. So that I know is a very expensive roof to get done right there.
Well, they can taper the insulation
Sure.
to match the parapet. I don't think the parapet wall needs undoubtedly needs to be raised. I don't know how you feel about that, Mike.
I'd have to see a detail, but I know what you're saying, and you can taper it so that but you don't want to necessarily create a gutter there and have water standing on the edge of the roof against the parapet. So, if you could taper it in 2 directions and maybe put some kind of scuppers or something through the parapet, or make sure there's a way for it to drain away.
I think part of the problem is that there's already scuppers there
No, they'd
And
cover
they
the
dump,
scuppers.
they dump onto the lower roofs.
So they'd cover the scuppers and then they'd have nowhere for the water to,
Right. And you don't want it running down the side of the building.
no, getting the brick saturated, no.
Yeah.
Those 20-year roofs, Mike, what kind of roofs? I don't remember what kind of roofs they are, but on the 20-year parts of the buildings, are those worth doing? What do you call it? A reconditioning, Craig? Is that what?
Now, restoration.
Restoration.
Is that a built up roof? It's a,
Yes.
yeah, those work, if there's no leaks. So what I've seen done is they go through a roof with an infrared camera and they look to make sure there's no water damage underneath, no saturation. If the insulation's saturated underneath it, it's become compressed and it's not functioning as insulation anymore. It's just a layer of mush. But if the insulation's good and firm and the R value is where you want it to be, I've seen that work very well. But to your point, you have to catch it before the roof is completely shot.
Yeah. And those roofs, I think, would be good for it because they are only 20 years old at this point.
Probably
So
okay.
I would think they'd be good candidates for it.
Yeah, I do agree that coring it would be a good idea as well. So you have a feel for how compressed the insulation's gone and if there's any water. But we have a infrared camera we use that does a pretty good job of catching water. If you go out on a cold night, it's been a warm day and then a cold night, the water that's in the roof membrane or under the roof membrane pops up pretty quickly. It's pretty easy to see it.
Yeah,
I
the
guess
other
along
thing to
those
consider
lines,
too is if we come up with a HVAC system that we do away with the rooftop units, there'd be a lot of patching to do on that roof.
Yep. You gotta fix the deck and then add insulation to match existing. I've seen it done a couple of different ways where they just if there's nothing going back, that they'll put metal deck there where the curb is and insulate it all the way up to the top of the curb and just put a membrane on top of that. And just, you'll see where the rooftop unit once was. It just kind of looks like a small platform. Works okay. I've seen that on warehouses where they remove the rooftop units. And so
we had that issue at Mills Lawn on the 57 edition. There was a skylight that ran the length of the classroom section, and it was we had to tear them out because they were leaking so much. And that's what they did, is they decked the top of that and then roofed over top of it. So you could tell where it was, but it was roofed over. Now I don't know if that has been changed since that last roof was put on or not.
When we talk about a roof restoration, how much can that get us in terms of extended lifetime?
20 to 30 years.
And then you say that a traditional roof can only tolerate 2 restorations. Is that
Well,
right?
my experience is after 2 layers, the jurisdiction having authority, the concern is you're putting too much weight on the roof. All right, so the roof has got to have a certain live load and dead load capacity. If you put too many layers of roofing, it's generally very heavy. And then you have a heavy snowstorm, you could overload the roof. So the jurisdiction having authority, either you have to prove to them that the roof structure can take it by, doing a sample and having a structural engineer say, okay, a cubic foot or a square foot of this roof weighs this much. The roof's designed to this capacity. And then you have the ability to take a snowfall, right? If you can convince the jurisdiction, then they're okay with it. Otherwise, they generally get pretty persnickety about more than 2 layers.
And have we had already a restoration? Have we used up those 2 layers already, or where?
We have done one restoration on the 3-story section of the high
Michael.
school and the I guess, the main section of the high school, the first floor level, those have been restored. The last time, that was back when I was there. I'm not sure what year that was. So it's been restored once, because what we did is we had it restored with the white coating,
Yeah,
so that we could realize some,
reflective heat.
yeah,
Yeah, that turned out to be a big boondoggle. I don't know if you've ever followed up with that.
well, if you look at them now, you couldn't tell that it was
Yeah.
white at one time.
Right.
And that was at Mills Lawn and the middle school and high school, or?
That was just at the high school that I'm referring to. Mills Lawn, the main section, I think that may have been restored once, but I could be wrong with that.
Is that
Well-
something that we can get from the assessments that you've done, Mike?
I think that I'd have to talk to Tim. I think he would recommend a core, to have a roofer go out there and do a core and, make sure we know where each core was taken, and then he could evaluate it. And he certainly would be able to tell us if we can add additional layers or if it's beyond the capacity. I think we have enough we should have structural drawings or be able to ascertain the structure. And he should be able to do the math and tell us whether or not you can add.
I think the problem you may run into, especially at Mills Lawn, is lack of drawings.
Yeah.
Excuse me. We do not have any drawings of Mills Lawn except for what we can call the annex, the 57 section. There
Okay.
are no drawings available, unfortunately.
Okay.
And I haven't been
I
able to
think that
tell
Mills Lawn
anybody.
roof is the 52 section is reinforced concrete.
I've tried to explain to people, it's like block laid sideways is what it looks like. If you go in the boiler room, you can look at the ceiling, and there's no roofer that I've ever had out there that's been able to tell me exactly what that is.
So it's spanning the structural components are spanning the joists.
well,
There's no joist.
There's no joists.
Oh.
So
Okay.
it's like a poured concrete deck, except it's not.
Oh, it's a precast deck?
Well, it's like I say, it looks like concrete block that you've
Okay.
laid flatways
Okay,
and not staggered brick pattern, but just regular stacked.
okay.
So I'm not sure if that's what they used to call the
Flexicor.
Flexicor. Thank you.
Okay, yeah, I'm familiar with Flexicor, sure. It's
Yeah. So this might be an early version of Flexicor.
precast, pre-stressed. I thought I saw Flexicor, so maybe that's what I was looking at, but yeah, precast, pre-stressed, it's got hollow cores in it. And they
Yeah,
span the width of the roof.
The high school that's what the high school has, is that.
Okay, that's what I was-
Mills Lawn, I think that's maybe the early version of Flexicor on that roof.
okay.
Just guessing.
Well, Jack
one-
Klein did both of those, so he may use the same roofing system.
I was gonna say, I was thinking we should start kind of a running list of additional investigation. So it sounds like the core samples of the roofs. That's,
Yeah, they don't go all the way through the structure. They just core sample down to the structure. I
right.
try not to, and they should take some photographs. They should, whatever section they take out should be intact. So it's kind of a core, if you will, and then they should take some photographs of what that looks like before they patch it. So we get a feel for,
Is that
Okay.
something that THP,
I think
Does?
they
or
probably.
will we have our
hire-
own roofing folks that,
I would hire if you can't come up with a guy that's willing to do it, I think we could find a roofing contractor that does it, but that's typically who does it.
Mhm.
I don't think THP, well, they might. I'll ask Tim.
So did you say hiring our current roof company or asking them if that's something that they do? Is that what you said?
Yeah, it's pretty common.
Craig.
Roof contractors do it.
yeah, Craig Carter indicated that they do it. It was my impression when we talked to him.
That's who has done it for me in the past.
Yeah, most roofing contractors will have the necessary tools and ability to do an evaluation like that.
Now,
Right.
since we're talking about the roof, and I know that there were lots of questions from Richard about the fall prevention system, is that something that is added on top of a roof, or is that something that we need to think about before we
So-
do?
Tim answered that question, I thought, pretty well. So the concern is for your people, not necessarily the contractors. And in his answer, he said, I have to look for it, but I think he said that it's within 10 feet. Anything that's on the roof that gets maintained, like an air handler or a rooftop unit, that's within 10 feet, or maybe it was 8 feet of the.
No, it's
of
10.
10 feet of a
Yeah.
potential fall, there is supposed to be some kind of fall protection. Now, the guy can wear a harness that has an 8-foot lanyard, so he can't possibly fall off the roof. That's fall protection. Or you can have some kind of assembly that you can set up just for that event. Or you can set up permanent fall protection. We typically try to make sure our air handlers are well within the center of the building or not on the edge, just to prevent this issue. His biggest concern was, I think, your access hatch, that
Yes.
you go up the ladder, you come out the access, and boy, you could fall right off the building. So, you know, you could set up some kind of temporary, you can set up some way for once you open the hatch, that's your fall protection. But it's pretty common that there is fall protection around a hatch if it's on the edge of a building. I think that was his biggest concern.
Yeah, my question was more in which order to proceed, because it sounds like it's tied to whatever HVAC system we have on top, right?
I wouldn't worry about it until you do something with your HVAC system. If you want to protect the roof hatch now, you could probably come up with a way to add some kind of anchors to the edge of the roof, and then have a slide in aluminum or steel painted galvanized steel handrail or something, just to resolve that one issue. But with respect to the rest of it, I wouldn't get too worried about it until it's time to put the new rooftop units on there.
There are ballasted handrail systems that
Right.
can be purchased that just set on top of the roof.
That's true too. And you put a block or you put a bag of some gravel or something on it to keep it down. That is true.
Dorothy, you were asking about roofers. The roofers bring their own protection to work on the roof.
Correct.
Yeah, I was, I think, asking more the order in which to proceed, if that's the way that we're going to go. Since we're talking about patching the roof or restoring the roof or replacing the roof, I was wondering which order to go when to think about that.
You mean in terms of, I would say you would plan for that fall protection to be in place, and the roofing contractor can either install it, or he can have a sub come in and weld it if you're going to do it that way. If you're going to do a ballasted system, then you don't have to worry about it until the roof's down. But yeah, that would be the time to figure out your fall protection is as you're designing your new roof.
Okay, and as we're designing our new roof, should we also have an idea of what the changes with HVAC are if we're redesigning a heating system? Because it might change what is sitting on the roof. Am
For
I
sure.
understanding this right?
Absolutely. If you decide to replace your rooftop equipment, and you want to have a larger unit that has more capacity to serve more of your building, then you would want to evaluate the weight, see if there's any kind of structural change you need to make. Also, the curbs would have to be different. It's very unlikely you'd be able to pick up an old unit and drop a new unit right on that same curb, and it's going to fit properly, and the takeoffs from the bottom of the unit are going to fall directly into your ductwork. So there's always issues there related to the bottom of the new unit and how it fits on the curb. So again, all that gets evaluated. If the curbs the other issue could be the curb is deteriorating. You know, back in the day, they used to have metal clad wood curbs and the wood would rot and the curb would fall apart. So typically the curb is replaced anyway because it's usually damaged or rusted or rotten. Occasionally they're okay. And if that's the case, then you can reuse it provided the new air handler fits directly on it, which again is very uncommon. Usually the curb is replaced with the unit. The roof has to be made larger. The roof opening rather has to be made larger. And if the unit is heavier, there may or may not be structural improvements that have to be made. So it gets pretty messy. It can get pretty messy. And an operation like that would be ideal in the summer. So if you were going to replace all your rooftop units, you'd have them ready to go. It's first day school's out. You cut into the old roof, replace the curbs, do any kind of structural improvement you have to make, get everything set, and then re-roof the whole thing, and then set the units down after everything's been re-roofed. That would be my recommendation, or some permeation of that. We've done that many times, so you can do that in the summer if it's well planned. That's usually not a problem.
Mike, while we're on this subject,
Yes, sir.
what do you think the premium would be if, in fact, our two-pipe boiler system, the piping is in pretty good shape, doesn't have to be replaced, and you replace the rooftop units with a two-pipe chilled water system? What kind of premium do you think that would be versus replacing the rooftop units? And maybe also address the efficiency issue.
Well, that's a good question. Brad, my one of my colleagues here and I were just talking about that the other day when we had Mike Richley on the phone. We were talking different systems. I like the idea of a two-pipe heating and cooling system. You know, you have a shoulder period where it's, you know, heating season starts next month. You can turn the chilled water off and then, you know, repurpose it for hot water. You know, a lot of universities do that. Xavier University does that to this day. That's their system. It works very well. You would have to replace the guts of the unit ventilators, right? Those would all have to have new, you know, the coil's a bit of a compromise, right? The coil's got to work both for heating and cooling. So it's not perfect for either, but it's generally made big enough that you can overcome any inefficiencies that you might see because it's not a heating or cooling coil. It works very well. I think your efficiency, overall, your energy consumption should be significantly less. Rooftop units are very wasteful. In the spectrum of mechanical systems, they're very wasteful, especially if you're using it for heat, because that furnace up there in the rooftop units, at best, a 70% efficiency, even though it's 80%. As it gets older, it loses its efficiency. You're making hot air inside of a box on a cold roof, so you're losing some of the heat there. Ductwork, air distribution of ductwork generally is fairly inefficient. You have all that fan energy as well. I like the idea of a chiller and a boiler and a two-pipe system. The chiller wouldn't have to be that big. You probably could get away with a 100-ton chiller. It could be a geothermal chiller, which would be very efficient as well. It could be a heat pump chiller, so you have only one unit. It's both heating and cooling. The heat pump chiller would heat and cool. You might need to supplement it with a small boiler, but I think that'd be a very efficient system. In order to truly do it, I'd have to do an estimate side by side. And I've told Judith I would be happy to do that if we could settle on a couple of different systems. I don't want to do it for the universe of every system available. I've also thought that a VRF system might be interesting over there. They're heat pumps, so it's heat and cool. You can buy a VRF system that would fit inside the unit ventilator cabinet. So, you could take the cabinet cover off and sandblast it and painted and put it back on. From a fit and finish, you wouldn't know any different, but that piece of equipment behind there would be a VRF system, and it would heat and cool, and that would be refrigerant running. You'd have to run refrigerant pipes. So this was my thinking in the event that the pipe has failed. So if we discover those pipes are no good, the cost to do the new piping is generally very expensive. It's about, gosh, $15 a linear foot, maybe a little bit more, because it's all got to be insulated, and it's in a hard to get to area, but typically it's $15 to $20 a linear foot. If the two pipe system was shot, then my recommendation was either water source heat pumps and have heating and cooling in those cabinets, or a VRF system, you have heating and cooling in those cabinets, and try to get away from the rooftop units if you can. And that way you
While
don't
we're
have
on
to go on the roof. I'm sorry, I interrupt. I'm sorry, go ahead.
No, it's okay. Go ahead.
Well, that way you get away from the rooftop units. You can cover your roof. You don't have anybody up there necessarily anymore for any maintaining of the rooftops. Rooftop units are a 20-year item, and then you're replacing it. Hot water, chilled water, VR or unit ventilator would be a 50-year or 40-year system, and probably last easily into another 30 or 40 years. VRF is not as long lived. The technology is not as old, so we're not sure how long it'll last. The first edition of the VRF systems didn't do very well. Some of the stuff that's being made now is much better, and so we have confidence that it'll go 20 to 25 years. A water source heat pump system is very good, but you have compressors in all those cabinets. So all those cabinets would have a little small, maybe a 3-ton or 4-ton compressor, which may be noisy, maybe an issue that, distracts the teacher and the students. Well, they're pretty quiet, but you would hear it, of course. And then you have all those compressors that need maintenance. You'd have to go in and replace the compressor every 10 years or so as it fails. But that is a very efficient system. The water source heat pump, if you're just circulating water in the summer, you got a small cooling tower. And in the winter, you got a small boiler, and you don't need nearly the size of boilers you have now. It's much smaller, and you don't have to get the water as hot. So it is a very efficient system. I'm sorry.
So that means we would need to build a water tower? Is that what?
No, it would be something that would sit on the ground, not on your roof, and it would be much smaller. It would be a cooling tower, so it would be water would be pumped back to it, and it would have the process of evaporative cooling, but it would be much smaller. It would be maybe 10 foot by 3 feet or something. It wouldn't.
And you said it works really well, so it would be the main issue in both building in terms of temperature is how hot it gets, and so that would work to cool off both buildings.
Yeah,
and it would work well.
Yes, well, we would size each device in each room to be able to handle whatever the heat load is. So yeah, if it doesn't work, it would be your engineer's fault. The equipment will work. You just have to size the equipment to cool the room, and it would blow just like it does now. You wouldn't need ductwork. That's the other issue, is you don't have much ceiling space, so there's not much space for ductwork. And if you can avoid that, then you can, and if you can also put it back into that cabinet that already exists, then you don't have to buy a bunch of new stuff along the wall, and it's the finish looks a lot better. It's not as new and old compatible. So,
and that could be used to cool the gym as well, because right now there's no AC.
The gym is probably, if the roof is not strong enough to take a rooftop unit, then the gym is probably a unit that's mounted on the ground with ductwork that runs up either inside or outside the building, and then runs out across the top of the gym underneath, not on the roof, but underneath the roof. either one or two long sheet metal runs that blow down into the roof or into the gym. So ideally, you want to put it on the roof if the roof's strong enough to take it, and then it comes right through the roof and then runs in either probably in two lengths, and then you exhaust it, some other way. It's not necessarily a return through there. It would be either returned indirectly or it'd be 100% fresh air. The gym air conditioning is a summer thing, right? Are you using the gym in the summer, or is this kind of a spring, fall air conditioning? Because you're probably not air conditioning it in the winter, right?
I think in the summer it is used. I don't know how much, but it is being used to some extent, my understanding.
Okay.
Maybe actually the question is it underused in the summer because it's so unbearably hot?
Okay.
Yeah, that could be.
Yeah.
I had a couple of, at some point, Michael, you had talked about levels of efficiency and how really high level efficiency, I think you were talking about heating units, only last 10 to 15 years, that the next step down, they'll last 40 years. I guess I just wanted to say it at this juncture where we're talking about HVAC. In my mind, efficiency also involves how often you have to replace something. And so, I think we should keep that in mind. And one thing, going back to the roof issue, if we're not replacing a roof, say to start with, and we're, like the roof over the modular, for example, and I don't know if this is true in any of the roofs at Mills Lawn, is still under warranty, is what we were told. In terms of a maintenance plan, when you're trying to save money, so that you have the money when it's time to replace that roof or restore it, is that part of the maintenance plan in terms of including that cost that you're setting? I don't know, are you setting it aside? That's the way most homeowners would do. You set the money aside, and then when you have enough, as you're planning for when you're going to need to replace that roof. What do you recommend in terms of being kind of prepared to take care of things when they need to be taken care of?
So a lot of my university clients and some of the bigger public schools where they have, multiple buildings, they have what they call a sinking fund. And that accrues money. They put money into it every year. They do a overall study of what they think an annual maintenance budget should be, knowing that, every X number of years you're going to recarpet, X number of years you're going to re-roof, X number of years you're going to repaint, and you're going to do some other things that are on some infrequent basis, some predictable basis, and they try to calculate what that will cost over time, right? Total cost to ownership, and take 50 years as reasonable amount of life cycle, and then they try to make sure they have money in that account they put money into that account every year. So when they do have to replace the carpet, the money's there. When they do have to replace the roof, the money's there. And it's just the way they internally budget it. Now, I have other university clients that run from empty bucket to empty bucket, right? Every major project is a crisis. And they got to either go ask somebody, an alumni, or they have to go beg somebody for the money to do it. And their buildings generally degrade over time because they just don't have the budget to do it. That was one of the questions I was asked by Mike Richley, is on a list of everything that we recommended, both PHP and Motz, what are must-dos, what need to happen in the next, year to 3 years, and then what are maybe 5 years and longer. So I'm in the process of sorting all that out.
Mike, getting back to the heating system, does it make sense, and is it appropriate to use some non-destructive testing methods like an ultrasonic testing device to check out that piping and give us an idea whether we can use it or not?
What I would recommend is we actually take samples and we cut, in a couple of areas, we cut a foot or two out and, we repair it, put new pipe right back. But that would take those pieces of pipe and I send them to a lab I use and they do metallurgical evaluation of the pipe. And they also do wall thickness and determine how much of the wall of the pipe has been, worn away. And they'll give me, this pipe will last another 20 years, 40 years. They also do some kind of metallurgical brittleness analysis on it as well. And they'll give me a report on what they think of that pipe. They don't guarantee anything. Nobody guarantees anything, but they will tell me you can go another, 50 years probably. This pipe is as good as it was when it was new, or this pipe's very brittle and you're going to start seeing problems with it. Don't use it. They'll give me generally a good thumbs up or a thumbs down. So that's what I would recommend. And that's probably the closest to science I can get to it. Observing it isn't necessarily going to just, looking inside the pipe isn't necessarily going to do it for me. Although, and my understanding is you haven't had any issues with it. Your maintenance guy tells me it's been pretty good. Your current maintenance guy, there isn't any leaks in it. Is that true?
So just determining the metal thickness of the pipe isn't sufficient.
That is very important. The thickness of the sidewall thickness of the pipe is the primary answer. Yes, that is true. But also, is there any, what they do is they saw the pipe in lengthways in half and look at it and see if there's any ionic or any kind of metal reaction, if there's pitting, or if the inside of that pipe has been oxidizing and is rusting away. And they look at it with their microscope, their electron microscope, and tell me how, the real thickness to that wall, it's because 20% of it's eroded and it doesn't have any strength left, is 80% or whatever. So they'll give me some basis to have confidence, and you have confidence that what we're doing is the right thing to do. So that's what I would recommend. It's not very expensive. You're just cutting it sections, couple of sections out, probably the furthest away from the boilers as we can be, and maybe something in the middle and then something close to the boiler. And we're, I'm only looking for a 6-inch piece.
I'd like to add something about Mills Lawn. Remember when I worked there, I came across some drawings from 1978 when they changed what was then the steam boilers over to hot water. And they replaced all of the piping around the perimeter of the 1953 section with copper.
Okay.
So that was changed in 1978, from what I understand. Now, those drawings, I assume, would still be available to look at.
Okay.
But that might change your thought. I mean, not to say you don't want to do a sample, you certainly do, but I'm thinking that the age of the pipes around the perimeter of the 53 section are not as old as 1953.
Well, and I like the fact that it's copper. It generally survives better. The steel tends to get, oxidized. So no, that's good news. That's good. And we would go back with copper anywhere that we were replacing it. It's faster and easier and less expensive. Versus welded steel. Okay, that's good to know. I do remember looking at some stuff that to me looked like steam pipe and a steam valve, and I made that note in my one of my reports, and Mr. Zoff caught it, and he's like, "Steam valve? What are you talking about?" So I'm glad to know there was steam there. I wasn't seeing things. That's good.
There was, and in the room across from the office, there's a room that it used to be a technology room, but they store paper and things in there now. There's a section of floor plywood that if you lift that up, there was some steam equipment in there, which is probably still there.
Okay. Steam trap, the trap in there?
Yeah.
Yeah. Okay.
So when we talk about pipes, are we talking about the ones used for heating or one for just any water consumption in the
Yeah,
building?
this is heating, it's a supply and return from the boiler to each of the unit ventilators that are against the walls, the perimeter walls. So there's two pipes, one's supply, one's return. It runs the length of the building or the perimeter, and you use it to bring the hot water to the unit ventilator and the return water back. And what we would do is repurpose that pipe to both be heating and cooling. In the summer, you would run chilled water through it, and each of those unit ventilators would have a chilled water coil. And then in the winter, you'd run hot water through it, and each of those unit ventilators would have the same coil, but that coil would now be for heating. And there'd be fans blowing the air across the coil into the room.
Okay. And how does it change humidity in the room? Does it help regulate humidity as well?
To a degree, it's not as good as that is probably the primary drawback. It's not as good at humidity control as a VRF system or as a dedicated air handler ductwork system. The best VAV or the best humidity control method is probably a VAV box with a hot water reheat. So you can chill the air down really well, get all the moisture out of it, and then reheat it a little bit before it goes into the room so people are comfortable. That's probably the best way to control the humidity, unless you're talking about a skating rink or something really complicated, then it's a different thing.
So do you think that this is something that we will need in terms of?
No, I think we could probably get it to control. So there will be a lot of humidity removed. So the way the unit ventilator works is it pulls in room air. So through the bottom of it, it'll pull back all the room air and it'll go up through the cabinet. The chilled water coil will have a condensation tray underneath it. The air will blow across the chilled water coil. We'll be able to wring out quite a bit of the moisture, and then it'll blow the cool air, dehumidified air back into the room. So the way we would control the humidity there would be with airspeed, how fast we blow in the air across the coil, and then how cold we get the coil. So we probably want to circulate pretty cold water, and then we could regulate humidity by either speeding the fan up or slowing the fan down.
Okay.
But
And
again, it's not as precise. It's not as precise. So, but I think for the classroom, we could get it very close to comfort level. We could get comfort levels there that everybody would be okay with. Maybe on Monday morning, if you don't turn the air conditioning on in the weekend, Monday morning, it might be a little stuffy, but generally it should be fine.
And then what about air exchange and air quality?
So
Airflow. Yeah.
what you would do with those cabinet unit heaters is we would probably, and they may already exist, but we probably core a hole. We could do it one of two ways. We can put a dedicated outdoor air unit, and we could pump fresh air into each of the rooms through a ductwork system. That's one way to do it. And that way, each room is getting fresh air. There's no question about how much we'd specifically size ductwork to each room. And it's not big ductwork. The fresh air requirement, when you add it all up, isn't a huge amount of ductwork. It's a relatively small amount of ductwork to each room. That's one option. But you got to run ductwork, and you have to have a DOAS or a dedicated outdoor air unit. The other option is to core a hole in the brick wall right behind on the perimeter, right behind the cabinet unit heater, and you put a little fresh air intake there. And so the cabinet brings in air as it needs it, and it's using, sensing equipment to determine how much CO2 is in the air. So you don't necessarily need to bring in a lot of fresh air. You need to bring in what you need in order to keep the CO2 levels to a certain set point. So it would open and close as necessary to bring in fresh air, and then you would have the amount of air in the room, and that is one way to do it.
Mike,
Now,
can
Yeah,
I
I
interrupt?
What,
I'm sorry.
what are the
I'm sorry, can
typical?
I interrupt for 1 second?
I'm sorry.
All of the unit ventilators at the high school have louvers
Okay.
with outside, so the outside air thing already exists. Now they're probably, in fact, I can guarantee you they're not being used because the equipment in that cabinets are
Yeah. 70 years old.
yeah, but there are louvers to the outside.
Yeah.
There now, so there is an access to fresh air.
Yeah. The downside to that is it's a hole in your perimeter, right? So water can get in it, animals can get in it. That if that damper starts failing, it's generally something you don't know until one day it's super cold in the room, in the winter because the damper's stuck open or something.
Or they're frozen.
Or they're frozen. So that's the downside, that you've got this hole you've intentionally put in the exterior of your building, and it needs to be maintained. That's the problem. And the animals can get to the insect screen. You can also clog it up with a mower if a guy goes by there and mows the grass and blows it on there, or weed whacks and gets it in there. You can get it clogged up with that too, or insects. So it's not an ideal solution. The DOAS is a better solution, but it's also much more expensive. I'm sorry, Michael, you were asking a question. I didn't mean to.
I'm good.
Okay.
Do we want to?
Well, I guess, and some of these other places that have the chilled water, in your experience, what are they utilizing for?
Well, they would use a
Quality air.
DOAS. They would use a
The
DOAS
DOAS.
unit and run the chilled water to it. So a DOAS unit is a small air handler, right? And it would be pulling in outside air. You don't want to just pump that hot, humid air into each room. So it'd be going either through a chilled water coil to get down to a comfortable temperature, and then it goes straight into the room, or it's going to go through a heating coil where it's going to heat it up. If it's in the winter, it's going to heat it up and then dump it into the room. But a DOAS unit is definitely a better solution because you can be very precise about how much air you get into each room. And it also could be an energy savings because you can pull air out through the DOAS unit and go through a heat exchanger and save some heating energy and some cooling energy as well. So it's usually double duty. It works for as I say, energy savings as well as fresh air. But it's an expensive thing. You got to run ductwork. You got to find a place to put it. You got to find a place to run the ductwork, right? Or we're going to run the ductwork on the roof, or we're going to run it, in the ceiling space, which isn't very much. You probably could do it in the ceiling space, but you got to take the ceiling down to get to the ceiling space. So, depending on, how much you can afford.
Hey, Craig, didn't they have that at Oakwood, or what were they using? Do you remember? In the
No.
rooms?
I do not remember.
I remember they mentioned a DOAS, and they
I
say
think they were in each
DOAS.
room.
they were in each room. Wasn't that the cassette that they had on the ceiling?
Yeah, the
It
It was in
VRF
the
cassette.
ceiling.
That was
middle
in
of
the
the ceiling.
ceiling, and they
Yeah.
had to lower the ceiling and then they had to accommodate the original windows that went up to the original height, and so there was that weird drop ceiling in the off the wall.
Little pocket.
Yeah.
Yeah.
And they seem to say that they were not too happy with that system. I remember there was a negative comment about DOAS, and I cannot remember why.
The DOAS or VRF?
I do not know anymore.
Okay.
I remember one teacher, because we I think Judith asked this one teacher about comfort level in her classroom, and she was very happy with that, but that was probably a different conversation.
The drawback for DOAS or for VRF is you have the cassettes. So you have one location in the room that generally gets most of the air. And so that space can be really cold, and then the space 10 feet away, not so cold. So part of the challenge is distributing the air in the room so that it's even. The other comment I get a lot of times with the VRF is it's loud, because that each cassette has its own fan. So you have, especially if you've got a fairly large room where you got 5 tons or 7.5 tons of cooling, those fans can get pretty big. They can get, they're scrolls, but they can get pretty big and they can be noisy. But once you get the room cool, and each teacher's got their own controls, typically, they got a little handheld remote. Once they get in the room, they can silence it, or, if they're doing a slideshow or it's a test period, they could reduce the fan level, so it's a little quieter. But I mean, that's generally the complaint, is it's a spot, one spot's colder than the other, and they're noisy.
But they'd have to choose between quiet and temperature control.
Correct. Compromise, like we all do, right?
Mhm.
So yeah.
I wondered if we should move on to the electric system.
Okay.
Just thinking about the different systems. I know, David, you had some questions, or you would talk to somebody. I don't know if you want to share that. And
Dave, you're muted, I think.
Yep. Yep, just turning it off. So, Mike, you mentioned that the 208 service was pretty much obsolete and that within 10 years it might be gone and unavailable to us. There's no plans for DP&L or the village to get rid of the 208. They will be continuing to supply it.
Okay.
Or is there concerned for as long as
There's
electric's around?
customers. As long as there's customers.
Yeah. So that should take, that would take a big amount of money out of it. The switches, you mentioned then that we should really redo the switches that are old, but the switches typically are not replaced because they don't get used much. They get very little wear. So even an old switch should still stay working perfectly. Now breakers, that's a different thing, where we have the pushmatics and we want to just update. They should all probably be they could all be redone. But the other thing is, you mentioned that we would have to increase our whole electrical system to cope with a new build. But if the new build was separated from the existing building, the majority of it was separated by a corridor with open doors, doesn't have to be sealed, then it could have its own electric system, which
Sure.
wouldn't even have to be the 208. It could be whatever we want. And that would save us having to change all of what we've got, which would be a huge savings for us as well.
I agree with your statement there. I think my argument for replacing the primary gear isn't necessarily because the switches don't get exercised. It's because if you do have a failure, you're not going to buy a new switch. The switches are no longer made. You're kind of stuck. You could take that old switch and find somebody who might be able to refurbish it, but for a period of time, you have no power to that circuit. And if it's catastrophic, if the switch, say you get struck by lightning or there's a dead short and that switch fuses and it's unrepairable, or the whole cabinet, you gotta buy a new piece of gear, and the gear is a year out. That's the concern. You're basically going to be stuck with a building that doesn't have electricity, or you're going to have to go through some very complicated repair. That's my primary concern. I agree with you that by and large electrical gear, and I've been in buildings where the electrical gear is very old. I mean, it looks like Thomas Edison put it in.
Yeah.
And it works perfectly fine. I've been in some very old federal buildings where they don't dare touch the gear because they know that if they start playing with it, they're going to break it. So I understand that completely. And I generally don't like the idea of doing that. I just think that you have gear that is, if it fails, it's, old Chicago Bulldog or whatever it is. If it fails, you're stuck. You're in a bad situation. So if you're going to do a renovation, and as far as 208 and 480, my primary concern with that is I think you use less energy, or you get charged less for 480. You get paid, you charge by the kilowatt, or you pay by the kilowatt. The 208 is a little bit more expensive to operate. And do you have to replace it? No. I mean, if the utility there, what we're being told by Duke here is anything that's 208, they want us to replace. They've asked us if we have 208 systems in buildings on clients, try to replace it, because they're trying to move those clients off the 208 and get into 480. So, I assume the utility there would have the same viewpoint, but that's fine. if you were to add a new space, I would agree with you. You could put a 480 transformer in or get a 480 power, and you could completely isolate that from the rest of the building. Totally agree with that.
Yeah.
So, but if you're going to do a big renovation, I would replace the rest of the gear in the building. I mean, some of those old panels just kind of look scary to me. The old distribution panels with the breakers. Finding new breakers is probably the push-o-matics. But if you are going to do a renovation and we order the equipment, I would love to see you get new primary gear. Most of the 2002 and newer gear that I saw was in perfect shape, and I wouldn't recommend you replace it. It's usually a 30-year or 40-year life cycle for panels. So anyway. Electricity is sometimes in the eye of the beholder too. My electrical engineer here is scared to death by all that old gear you have. Brad, one of my engineers here, he doesn't find anything wrong with it. So a lot of times it's in the eye of the beholder. So it becomes a challenge. What do we tell a client?
Now, we're mostly talking about the boxes and stuff themselves. We're not talking about all complete rewire and all that.
No, right.
Yeah.
Right. Now, if the wires, if we open it up and the wire insulation's all dried and fried, that's a problem. You're not talking about big, long runs, though. You're talking about relatively small runs. Right. But you're right. The labor associated with pulling the wire and new wire is generally the cost. The panel itself is not that expensive.
When you're talking about switching to the, 480 is it? Am I saying it right?
Yeah, 480 volts.
So how expensive is it? I mean, how much money, if we're trying to decide, do we do that or don't we do that? Or
Well, I could do a side-by-side comparison, but if you switch to 480, you would probably replace 3/4 of your electrical system. The wiring, not so much. Again, we'd want to look at any of the really old wiring. And some of that old wiring is probably shot, the insulation's dried up, and it's probably shot anyway. But if you were going to replace a 480 system, one advantage about not touching it is if you don't touch it, you don't necessarily have to upgrade every part of it. If you get into the system and you start finding problems, then jurisdiction having authority is going to want all of it replaced. So you have to be careful about what you want to do. But yeah, it would certainly be more expensive to upgrade to 480 than to strategically replace components with the 208. And then if you add something, go ahead.
but if we don't upgrade to that, I mean, how long before? You're talking about these switches are hard to find. I'm not talking about the pushmatics, but
the big gear, the primary and secondary distribution equipment you have, it's about a 1-year lead time for new panels, for new components. So if you were to lose one of those, to me, that's your single point of failure you have in your building. If you lose your electrical distribution, your primary, and secondary gear, there is really nothing you can do without replacing it. Depending on how it fails, there's really nothing you can do. You have to replace it. And it would be several months, if not a year, before a new piece was, I mean, there would be your electrical contractor would call every supply house in the country to try to find it. But right now, because of all the electrical manufacturers have not caught up yet with demand, and there's more demand, we're hearing, a lot of that gear is 12 months in lead time. So that's a problem.
How do you
Isn't
combine?
part of the idea of going to the 480 if we're going to go to HVAC and some of those newer systems that require that? Is that the premise?
Yeah, and my issue is that there is a lot more gear made in 480, air conditioning equipment, rooftop equipment, motors, than 208. And you can buy 208 equipment. There are companies that have told us that they're phasing that out. They're not doing 208 equipment. If the utility's gonna still, I mean, you can always take 480 and transform it to 208.
Right.
But it's, really at the end of the day, if the utilities are saying we're gonna provide 208 to you from the utility, then, and they have no intention of ever stopping, and, you can continue to use your 208. Our recommendation,
And do we,
go ahead.
do we need that for, we don't need that for the chilled water type of scenario, do we?
You can buy a chiller that would run on 208.
But we would have less choices in the chillers or in the HVAC equipment.
Well, we'd order it so we could pretty much get what we wanted. That's not something you buy off the shelf. We would order it and they would make it 208 for us.
Okay.
Again, my concern is that old gear and that losing it, not having a replacement.
And then we would have school closure.
Yeah, well, we wouldn't want that. So that's,
You would have a school closure for sure.
Yeah.
Or you
Other-
have,
go ahead. Other questions?
I did have one last question about electric system. So if we have a brand new addition that is on its own system, do we still need to have increased power in the existing building, especially if we start ventilating the gym, for instance? And how can we accommodate that on 208?
if you start adding, that's the other concern I have with the 208 system. It's relatively small in terms of its total amperage. And if you start adding a lot of gear, a lot of equipment, you're going to need to increase your capacity with the utility. And either by dropping a larger transformer or adding a second transformer. So you can get more done with fewer amps with 480 than you can do with 208. So that's one part of it. If you had a whole new section of the building, I think everybody would agree that 480 would be the right way to go with the new section. And if you added a new addition and you added air conditioning to the gym, we could run all of that through the new section. That wouldn't be, I don't, is an addition on the books? Is that an option, an addition, or is that something Mike's?
Yeah, Mike is looking at an addition.
Okay.
He's
Oh,
drawing
the
additions.
music rooms, the music,
Yeah.
we're talking Mills Lawn. Yeah, okay. Yeah, that is a consideration. The added equipment would probably tax your electrical system to its maximum. And you
I have a question about that. I mean, I know at some point in one of the reports, we talked about changing all of our lighting system over to LED.
Yes, that would
Which would
reduce
significantly lower.
Agree.
Yeah.
Agree. It would.
I don't know if that's enough to offset it.
Might be. We'd have to do a study. So what we would do is look at each panel and look at your secondary and primary gear. Look at, we'd get, I think I have it, but we'd get your utilization. How much have you used over the last year? And we would do the math on reducing your lighting and see how much was left. But it's possible that the lighting is a lot of load, and it is possible that you would reduce your overall load enough that you could get by. I would love to not leave you with just enough to get by. I'd love to leave you with a little.
Absolutely.
And to put it second, again, if you're doing the renovation, putting in a second piece of secondary gear. If you're upgrading your primary, instead of 2,000, you do 3,000, and put in a secondary section that leaves you some capacity. So for the future, isn't the worst thing in the world. I think over time we're using less energy per building per square foot, and that'll continue. But in the next 20 years, I don't know.
Several of you guys have had questions about the modular units.
Oh my gosh.
And so we wanted to hear your view on the conditions and so on.
My view,
Mhm.
this is a radioactive topic. I don't know. I think that my primary concern is, are we growing anything? Are there any biological hazards in that space where those modulars are? And, you know, underneath there, is it ventilated well enough? Are we comfortable that there's nothing growing down there that could be, you know, an issue for a kid? If that's the case and you guys want to keep them, then so be it. I've never seen anybody do what you've done, which is encapsulate the modulars. I've been in them, I've walked through them, and it's kind of hard to tell they're modulars. You know, they're not tinny or, you know, don't feel too cheap to me. I was kind of surprised that they are as good a shape as they are inside. But
Now, Mike, when you say, sorry, when you, am I muted? No, when you say that you've never seen it, you have probably seen a bunch of them because they're exactly the same as a modular home that's brought
no,
in.
I mean, I've never seen
brick clad.
anybody build a building around it. I've never seen anybody build a brick building around them. I've seen lots of modular units, yeah, but I've never seen somebody turn it into a building, enclosed it into and you know, incorporated it into the architecture. That's a first.
Now there's no chassis under those. They're actually they are pretty much, in fact, they may have come from that place up there on 70 that makes the houses, the prefabbed houses.
Okay.
So that's pretty much what they are with a brick cladding. There's no outside on them as far as I could make out between them and the brick wall.
Okay. There's no cavity.
Yeah, so they're not trailers.
Okay.
Like they're not mobile offices
I
that
got
were encapsulated. Yeah, it's actually a building. It's just a prefabbed building, and then you have to finish it when you get it.
But Craig was there when they were brought in. What do you know about him, Craig?
Well, that's exactly right. They're modular buildings. Like you can go out and buy a house now and they'll ship it in and put it on your foundation, and you know, they have to finish it, put the roof on and different things, but that's essentially what they did. You know, some of the way that they installed no, I shouldn't say that. When they installed it, there was no vapor barrier put on underneath. And it was inspected. Everything was inspected. It was up to code at the time. And I could never understand that because there was still grass growing when they put the modulars on top of the foundation, which it kind of blew me away, but that's the way it was.
I thought there was pea grass down there. Was there not? When
No,
I remember
no,
I was
there was
down
never.
under one of them.
It's just dirt. It's dust.
So it was
Dusty
just dry dirt.
Yes.
Yeah.
I mean, I would love to have somebody go in there and put a vapor barrier, or whether it's a spray liquid or it's plastic, but to make that area as dry as they can make it, and then ventilate it somehow, run from some dry air through there, exhaust it. That way we don't have biological stuff growing down there. To me, that was the primary concern. I think the other way, in any other way, we can heat and cool them, and we can add utilities, whatever they need, electricity or internet, whatever they need. There's really nothing preventing us from doing that. That was my only concern, is are we having a biological experiment down there underneath them?
Well, the foundation is a vented foundation, but part of the problem with that is, you know, like probably most of the houses that have vented foundations, you know, who goes around and shuts and opens them every spring and fall? It typically doesn't get done, especially if it's a prevailing wind coming into there and you're worried about freezing pipes and things like that. So, you know, the ventilation could possibly be there, but it just needs to be.
Well, crawl space dehumidifiers run about $1,000 a piece. it would be fairly easy to seal them up, put in 2 of those down there. So if there's humidity, it just sucks it right up and gets rid of it.
Yeah, mechanically ventilated, so that you know
Yeah,
it's
now-
happening, and have an access so that someone can go down there and inspect it once a year and make sure there's not a bear living
There's
down
a
there.
huge access.
Yeah,
There's a
There.
big access in one of the classrooms,
Okay,
and it's got about, I don't know, about 4 foot of headroom. So it's really easy to move around down there.
okay. I mean, that was my concern. I know that there's some structural issues that can be fixed. The structural engineer wasn't bothered by them at all. He thought they could be fixed. So other than that, I don't really have any issue with it. It's just
I mean,
unusual.
from your perspective, Mike, if it's free space, is it, I mean, if we knock it down, we're just throwing away space that could be used for something, anything from storage to small offices for teachers. I mean, if it could be, do you think it could be, at a relatively reasonable cost, made good space as long as no biological activity?
Sure.
Yeah.
Sure.
The structural issue there is a matter of floor deflection and the perception of a bouncy floor. It's not that there's a structural failure imminent. It's just a human perception problem, and that can be modified. That can be mitigated by some additional supports under the floor to take care of the bounciness. There are situations like that in commercial buildings around Dayton that I've experienced, where you just walk across the floor on a second-story building, on a modern second-story building, and you get some deflection in the floor beams.
I understand. Yeah,
like
that could
Fairfield
easily
County
be,
Mall or
There could-
Fairfield Mall.
Yeah,
it could easily
Exactly.
be fixed. That could easily be fixed. There was, I thought, some brick bulging on one side of the building because there was some detail where the brick laid on the block that was causing it to fall away a little bit. So maybe it's not a structural issue, maybe it's more cosmetic, but isn't that the case? Wasn't there some?
It seems like there was something on the south side.
Yeah, it's nothing serious. It can be redone. And maybe it's not a structural, it's just, it's a detail that needs to be looked at. But yeah, you could easily put in some, grade beams and concrete grade beams in that crawl space. And again, Mike Richley is going to kill me for saying this, but you could easily put the crawl space, grade beams in there and support the floor and make it less bouncy or no bounce.
Yeah.
there is a situation on that south wall where the wall is mismatched with the foundation.
Right.
and Water runs down the south wall into
That's
the
the-
foundation.
That was what THP noted, and I think it was in some other reports, and I think some of you have mentioned it too. So, but again, that can be corrected.
Is there a way to price out, if it's worth keeping for some use, I'm not sure what, if we wanted to know, well, if we don't keep it, we're demolishing it, there's a cost to that. There's the cost of, the HVAC, that the HVAC would need to be improved and, would be, so in terms of and then these kind of problems, we're talking about the moisture barrier and the bounciness, getting rid of the bounciness. I know a teacher complained it smelled like sewage in that part of the building. I don't know what's causing that. It doesn't seem appropriate to not have it addressed effectively. Any clue as to what that's about?
Odor.
Yes. Well, no, he was saying sewage. It sounded like it was coming from the toilets or the bathroom.
I was
There's-
thinking a vent pipe issue.
Yeah.
Well, I know at one point we had the sewer back up in the in that section in the shoebox, and it was all over in the carpet and everything. And I'm not sure if the carpet's been replaced since then. It's been cleaned, but that might be part of the issue right there.
That sounds kind of disgusting.
Yeah, it was.
Uh, hmm. Well,
Yeah,
anyway, could we get a price so we could, kind of know if it's,
Sure.
if there's a reason to consider trying to use the space for something else? People would want to know what the cost would be comparing it to.
We could get an estimate for, we could do an estimate for some kind of vapor barrier and mechanically ventilating the crawl space. We could certainly get an estimate for some kind of additional foundations that would allow, or something that would allow the floor to be reinforced so you don't have the deflection. I think all that could be done. And if there's air conditioning issues, that could also be estimated. Is it uncomfortable in there in the summer? It's hot.
Well, I think part of the problem is the age of the units and that they're electric
Yeah.
heat. So it's the cost of
Oh,
the
okay.
units plus the age of them.
Okay. Yeah. So that could easily be addressed.
Well,
Comment was made by the principal too, that they had to run the air conditioning in the summer just to keep the humidity down in those rooms. And that's probably related to these moisture issues.
Right.
Well, I think it would be worthwhile to try to get the cost on that. Don't you think so, you guys?
Yes, I think it would be helpful to know the cost of keeping it versus the cost of getting rid of it. As far as money, you're going to lose square footage. And I mean, I guess probably a secondary concern, but it would be interesting to know the cost of keeping it versus the cost of getting rid of it.
Well, we noticed when we walked through the schools that the need for storage space seemed very great. So there was, for example, that could potentially be a use.
Well, the thing is,
if it's dry.
Well, that's the thing. If you fix the issues that the building has, that would make those rooms perfectly usable for anything. I mean, even classroom space if you had to. Now, I know there's going to be a lot of pushback on that because they're thinking of it the way it is now versus the way it could be if you fix the issues. So all I'm saying is, if you leave an open mind with whatever you could use that space for, it's possible you could use the space for more than just storage or offices, but possibly some small classroom space. I'm not advocating, I'm just saying it's possible.
Yeah.
Do we want to talk about the masonry? I'm just trying to think of the different systems that we heard about from
There's
TH.
with asbestos as well on the exterior.
The Galva asbestos. I'm sorry, go ahead.
Yeah. Like, do we know that that's asbestos on those panels for sure, or it's still in question?
I think we were told that an environmental consultant told you that they were asbestos panels, metal asbestos, or some kind of composite material with asbestos in it. And it might not be a big percentage of asbestos. We typically encapsulate. Our recommendation is to encapsulate them and maintain them. My personal view, and this is not because I'm an architect, I just think they're ugly, that kind of corrugated metal. But as long as they're encapsulated, they're perfectly safe, right? There's no danger of any, somebody getting asbestosis from the panels.
Now you put up those panels, Craig, didn't you? The ribbons.
Say that again, I'm sorry.
Craig, didn't you install those ones, the corrugated panels?
No, those are original to the building. Now, the other panels that are in the stair towers, those were installed while I was there. So I know those do not contain asbestos. The corrugated panels that are in each classroom, those are original to the building. Now, you can access those from inside, you know, in the ceilings.
Okay,
And I don't know if that would tell you anything, or if you needed to do a core, you could do the core from that side, because, you know, if there's a sandwich in between, then at least you wouldn't be cutting a hole in the outside, you'd be cutting a hole in the inside. So you could theoretically test that pretty easily to see what is in the center of those.
okay.
But
I
they
thought there
could
was
just
an
speak up.
environmental report done. And Terry was pretty sure she knew where everything was in terms of hazard, that there was a report or a study done and a report given, and that report identified that as asbestos. But
Well, the thing is about, because they come and inspect, they used to inspect every 6 months while I was there, and I don't know if that's still the case. And then they would totally re-inspect every 3 years. That was the law. And there is a book on asbestos where all the asbestos is known and presumed.
okay,
So a lot of times what they would do is they would assume asbestos until tested.
oh, okay,
So it could be under the gray area where it's assumed asbestos, but they don't know because they didn't test it, because there was no reason to.
okay,
You know, they weren't being disturbed and they were intact and there was no reason to do it. So there's a couple different levels of yes, you have it, or we assume you have it, but we don't know for sure until you try to do something with it, and then it needs to be tested.
I got you.
My understanding is if you're doing a renovation plan, you would want an asbestos consulting group to be looking at the things that you're going to be disturbing. Is that how it's usually done?
Yes, there's typically a consultant that is a hazardous material consultant, and he or she would evaluate the building. We would discuss what work would be done, and then they would make a recommendation on what should be removed or what should be cleaned, and then provide typically a scope of work, and a contractor would bid on it, and he would be an abatement contractor who would come in and remove whatever was inside of his scope. In some cases, they can remove things in its entirety. They encapsulate it, like insulation on a pipe. They'll encapsulate it in plastic, cut each end of the pipe and take the whole pipe away. In some cases, they're removing specifically just the asbestos insulation or the tile floor, or these galvalume kind of panels, or whatever it is.
But Tim mentioned that those metal panels, there was some rust on them, so he had some concerns, wasn't that?
Well, I think he's talking about the like the gold colored panels.
Mhm.
Those are the ones that have the rust on them, and those are not asbestos. I can tell you
Okay.
that because we had them installed while I was there. So
Okay.
they're insulated panels, but they're not asbestos panels.
Okay.
If we're talking about
There-
They can be popped out and changed.
Yeah,
I was gonna say, I
They could
did
be
check
removed.
with the superintendent about the asbestos book, and it's in her office, she said, and I don't know, I was thinking, Craig, you, and I don't know if David has time. Maybe we could go over and take a look at it. I don't know. Would that be helpful? Or maybe it's not, if we're thinking we're gonna have to, you know, bring in an abatement company when we start thinking about what we're doing.
we could look at it and just see what the book says about those panels, if it has any information about them at all. And if it does, we could
Yeah.
see if they say they're assumed asbestos or whether they were actually tested, which I can't imagine is the case. But I
to
don't-
test, I mean, they would come in and take a coupon off of one of the panels. It doesn't need to be more than an inch by inch or something. And they send it to a lab. It's about a $200 test. It's not a big deal. And they can tell you what it is, and then you can go from there. But yeah, not a problem. There's a bunch of labs that do those kinds of tests.
Well, Craig, if you want to go over there and look at the book sometime, you know, we could
Okay.
probably make time to do that.
Okay. The other thing I was thinking, this is a little bit off of, but we're talking about testing things. So, we talked about doing pipe samples to make sure that the pipes are usable before we, so we know cost. I was thinking, roof cores, pipe sampling, the asbestos probably, maybe scoping the sewer lines and drain line, exterior and interior, just to see what we have. And if we did that relatively soon, we could really narrow our costs down as to whether we are replacing them or we don't have to.
I would also recommend maybe doing a electrical inspection of those old pieces of gear. And you have a professional NETA testing agency say, hey, these things are great, you can rebuild them, you're fine, or boy, you're living on borrowed time.
Yeah.
That would give me some confidence that we're not putting you in a position where you're going to have a shutdown, and or you would know a third party who's an expert in electrical testing would come in and tell you it's either okay or not okay.
Yeah, I think that's a good idea. While I was there, the village came around and they used an infrared scanner on the old panel at the high school.
Yeah.
And I'm sure they did at Mills Lawn too. And they scanned it and
No
they
hot
went in
spots.
and they opened it and they did some maintenance on them because they were
Okay.
finding some hot spots.
Oh, okay.
So there was some maintenance done. Now it's been 20 years ago.
Yeah.
But, and then I'm sure it needs to be looked at again. But
It's not a very expensive thing. An electrical testing guy can go in there and inspect it in a day. It's maybe $1,000. It's not an expensive thing.
Yeah.
We do it frequently before we go in and work on people's systems. So we have a professional tell us, and he'll be able to tell us you can't replace it, or you can, or you can't work on it, or you can. And he's kind of somebody we trust to give us good advice.
Yeah, I think if we got all these things taken care of relatively soon, we could really nail down our cost estimates for a lot of things.
It would help for sure.
Yeah, I
Then the
totally agree. I think we
comparison
need,
on the heating.
what'd you say, David?
And also we talked about the comparison for the heating and cooling systems. A price on, which way we would sort of go on that, because that's the other huge issue. Which type of system would be the most expensive?
If the piping is good, I think that puts you in one direction. If the piping is not good, I think it puts you in another direction.
Yeah.
I want to there's probably 10 ways to heat and cool that building. I'm happy giving you a price comparison, but I don't want to do it for all 10.
Yeah.
Can we narrow it down to 3?
Yeah.
That would be my request. But yeah, I think if you knew how your electrical system was, and you knew how the pipes were, and we knew how the roof was, I think you're right. You could make some decisions on how deep a renovation you have to do.
Yeah.
So if we talk about recommendations for 3 systems, I think you've talked about the chiller boiler system. Then you've talked, and that would come with a VRS, or it's one or the other?
One or the other.
Okay, but one of these 2 would come with a DOAS system, or both would come with DOAS systems?
Probably both would have to come with some kind of fresh air system. Yeah, either one.
So it's a chiller boiler system plus DOAS, and
Versus
a VRF
DOAS.
plus, sorry, what?
Sorry, yeah, you're right. Chiller boiler with a DOAS, or a VRF with a DOAS, or a water source heat pump with a DOAS.
So those would be the 3 systems that you would recommend.
At this point, if the piping's good, chiller boiler, I think, is a good option, and we could compare that to we could compare that to the other 2.
And then if a piping is not good, then what?
Well, then the chiller boiler system goes out the window, And you're probably looking at a VRF system, or you could repipe it. That would be the other option, is you could repipe it. But I think that would make that system too expensive ultimately. But so it would be,
How complicated is it for you to get a repiping estimate, just so that we know?
I mean, I can do an estimate on it. That's
Okay.
not, it's a linear footage kind of thing. It's not a problem.
I mean, I agree that, I agree with Craig, you know, this increased investigation. I mean, we're gonna have our meeting next week. To me, it would be good if we could decide at that point to get, you know, the core roof samples, the heating system pipes looked at, the electric inspection, and the sewer line inspected. Was there anything else? It seems to me like we're gonna need that information, and it doesn't sound like it's that hard to get it. And that we should just get that, because otherwise we're really not gonna know exactly where we stand. Is
Right.
that correct?
Yeah, that sounds right to me. We won't know how, there's too many ifs right now, because if this piping is good, then we can do this. If this is good, then we don't have to do that. Well, let's find out, because then we'll know.
Right.
The only other thing I would maybe recommend, and maybe you already have this information, is a water pressure in the street, or at one of the fire hydrants nearby, what kind of water flow and water pressure you have there. And it would also be good to know what kind of gas pressure you have in the street. Just in the event.
With the village, well, the village does the water. Are
The
they
village
the one
may
that?
have, the village may
They would
already
be
have
able to-
data on the water then.
Okay, and then the gas would be through the gas company. Okay,
You have to get a hold of Center Point Energy.
right.
And they may have pressure sensors in their system and would be able to tell you where the closest one is to the schools, and tell
Okay.
you, yeah, at that location, we have 12 inches or 16 inches of, you know, pressure or whatever.
So they're watching those pressures all the
Yeah,
time.
very typically they are, yes.
Mhm. Okay.
So they might be able to tell. I would love to know that, like in the middle of the winter, what that gas pressure is,
Mhm.
with the peak demand on it, and that would inform us as to the kind of equipment we could potentially replace it with.
Okay. By the way, Dorothy had asked about the smell of gas at Mills Lawn. Craig, you explained to me, but I can't repeat it. What is causing that? That's been an ongoing issue. Can you explain that?
That was
to us?
addressed in Richards, and he,
Okay,
which he said
Right.
something that I wasn't, I didn't realize, because we've been having although we've been having that smell issue since before the gas meter was on that side.
Oh, is that right?
Yeah, I think people are getting it mixed up with the burned gas smell, because the prevailing wind comes from that way and it blows across the top of the building and it comes into the front.
Okay.
And I know while I worked there, some of the previous principals, they called the fire department many times because people were saying they had the smell of gas, and the fire department would come in with their sniffers and they could never find anything. And I tried to explain to the principals, it's burned gas coming out of the
Flue.
chimney flues,
Oh,
and they're similar smells. And
So that led to a day of school closure last year.
Yeah.
Because the issue that happened is that it was very noticeable. And then what do? You don't know if it's an active leak or you don't know if it's burn. And it's a big gamble, right? So
Well-
that led to a day and a half of school closure, unplanned school closure last year.
Yeah.
While the systems were being investigated again. Because when there is a smell, you don't know if it's active or if it's burn gas.
yeah, it's
Most
been an
likely-
issue for as long as I was there and before, I'm sure. And I'm not sure how you remediate that, because, you know, the boilers, unless you get rid of the boilers, which, you know.
It could well be that the flue pipe is too low. It's not
Yes.
high enough, termination's not high enough, so you're getting a downdraft.
Well, the problem is,
I didn't
see,
know, Mike could probably know better than me.
well, before we had the new boilers in, we still had the problem with the old boilers, and it was coming out the chimney. the big tall chimney that's, you know, you can see, well, you can see it, it's 25 or 30 feet tall, and we still had the issue. When they put the new boilers in, they put, you know, shorter flues on
Yeah.
it. And I mean, we still have the issue. So I don't know if height will do anything, because it used to be high, and it's not anymore, and we're still getting the same thing.
Any suggestions, Michael?
Well, a high efficiency boiler, you generally just discharge CO2 and water. You don't really have any incomplete products of combustion. It's pretty much completely combusted. That would be one positive for a high efficiency boiler. So
Not
yeah,
those expensive ones that only last 10 years or something?
Yeah,
The
that's
next level
right.
down.
that's right.
Would the next level down work?
The next level, possibly, maybe a combustion issue. You know, it sounds to me like you're not having complete combustion. It could be a combustion issue, but I agree. If the prevailing wind is blowing it in that direction, it's really hard to prevent people from smelling it. We could move the boilers. If we put a VRF system in, we wouldn't need a boiler.
Yeah.
If you put a detection instrument in the stack, you could tell where the
Yeah.
gas was coming from.
Absolutely. We have some of those. We have those tools here in our office. Our commissioning guys have to evaluate incomplete combustion on a regular basis. So yeah, we could determine if the boilers are, if you have products of incomplete combustion, for sure.
Some of those, weren't some of those combustion vents closed or blocked off? Did I read that on Richard's report or someone's, maybe actually on your report?
Yeah, the Mills Lawn, I'm concerned isn't getting enough combustion air.
Combustion air.
Yeah.
Yeah, I
because
was gonna bring that up.
Yeah.
Does the current combustion air opening meet the code?
I don't think so. I think it's significantly less. I think you're pulling air out of the building, out of the upstairs, out of the building, and not from where it's coming from. I don't think it meets code, no.
Okay, I'd like to throw something in here. When those boilers were installed, we
had
had
that
an
loop.
issue with the burners basically blowing up because the particles were so fine of dirt were getting in the burners and causing a problem. So the manufacturer suggested to me to run ductwork in and into the side of the boiler with filters. So that's what I did, but I used the size that the boiler manufacturer told me to use as far as incoming air. So at the time, that's what we did. So it comes from directly from outside.
Okay,
It's piped with a 12 or whatever inch duct, and it's filtered, and it comes into the side of the boiler into a 12-inch opening, which was already there, which was
okay,
meant for, that's their air intake. So at the time, the air intake was sized to meet the boiler's needs.
okay. I might be getting the rooms mixed up. Is that the Mills Lawns where the is that the high school that's got the stair tower down?
That's got the louvers on the side. That's the high school.
Okay, well, the high
Yeah,
school.
that's the high school. That
Correct.
one, you're right. That one there is drawing from the outside.
Okay, that's the one that's not correct. The
Right.
one that's the combustion air is ducted into the side of the furnace is correct.
Okay,
Now, it
that's, yeah,
still might not be completely burning, and that might not have anything to do with, might be there's too much gas going to the boiler or the burner. So it might need just to be adjusted. But if you have complete combustion, it shouldn't smell.
yeah. Well,
Should.
those boilers have been serviced annually since we've had them, as far as they pull all the burners out every,
Is that MSD?
fall.
Is that MSD that does it, or who does it?
yeah,
They're pretty good.
yeah.
I don't have complaints about MSD. I mean, we can sample the flue products and tell you.
Yeah, that would be helpful.
Okay.
So my
Scott?
question is, how do we move ahead with this testing? Who's going to coordinate it?
I'm suggesting we talk about it next week at our facility committee meeting. And 2 days later will be the school board meeting, and it can be brought, if, we can bring it to the school board. Or superintendent maybe can by herself make that, could just decide to do it if we ask.
If we have a pricing, I think it would help make the decision for each of those in total.
Mm.
Okay.
Good point. Can you get that for us, Michael?
I can get the electrical, I
About-
can get a test, I can get the electrical guy to give me a price. I can get the camera, underground detective to give us a price on the camera work.
Is
So
that,
that's
you
for
talking about the
the
sewer?
sewage.
Yeah, the sanitary and a
Okay.
storm camera.
So you're gonna do the electric.
Piping coupons.
Yeah, I mean, MSD could do that. So we can ask them for a price to take sections out of, you probably want to do both schools, right? We want to do high school and
Yep.
Mills Lawn.
Yeah. I mean, I know Craig Carter talked about core samples that they've done that in terms of the roof. He could potentially get us prices on that, or can any of you other guys?
He'd be the one, because I don't know who he deals with anymore. I'd get whatever contract, or usually you have a manufacturer's rep that we deal with, and the manufacturer's rep will do all that.
Okay. The heating system pipes. Did we say who was?
I would, I mean, if you have a contact at MSD, at Mechanical Services of Dayton, that's who I would talk to. If you got a name or a phone number you want me to call them, I'm happy to do it. I will call my electrical inspection guy. Does MSD do plumbing, or do they just
Yes.
HVAC?
They don't for us, but they do plumbing, yes.
Well, they may have a camera. Most of the plumbing contractors in town have a camera, and they may be willing to do your sewer and storm system camera work. We can also get a quote from Underground Detective. They work all over the place. They're in Dayton. They did the Dayton Public Schools Stadium for us a couple months ago, so they would do it as well, and they're pretty competitive.
Craig?
Yes.
Would it be worth, when the camera guy is there, having him go to the back of the shoebox where the door comes out of the school? There's a concrete pad there and a downspout. It goes into a drain under that concrete pad, which is right against the back end of the box.
Yeah.
To throw a camera down there, just in case that leader is blocked and it's putting damp into the bottom of the into that crawl space, or adding to it.
Yeah, it certainly could be. I'd like to throw out the storm system that used to come out the back of the school before they put the addition on and all that. It runs underneath that interior, the indoor space or the outdoor space that's indoor, you know what I mean?
Oh yeah.
The courtyard.
The courtyard, thank you. Because there's storm drains there that are tied into it, and it goes out. And if you go out that door that you're talking about, there's a manhole there, and that's where it all dumps into. And then what
Okay.
it does is it goes straight back to that ditch back to the south of the high school, and it empties into there. So that's where the
Okay.
stormwater all empties into from there. So I'm sure that is tied into that system, but it certainly could be blocked up and allowing moisture to get into the building. So it'd be worth looking at for sure.
Yeah. Okay.
Well, what would be helpful is if there's things like that you guys want to have the camera looked into, have a list And when we talk to the camera companies, we say, here's the 10 things we want. And they'll come up and, drive around or walk around your building and confirm they can do it. So then they can give you a price that covers all that.
I have a
That-
question about the spreadsheet, if that's okay, and how you're going to show us those comparison. How you're going to compare the different scenarios on the spreadsheet? How is it going to look like?
On
Yeah.
electrical or on mechanical systems?
On all of those, I think that we've discussed about several scenarios. So we've talked about the HVAC. We've talked, I know that before we talked about a high efficiency boiler versus a new one. So I'm just wondering, are we going to be able to be able to compare easily those
Yeah.
different systems?
Yes, I would provide an estimate with the system. And how many, either it's going to be a linear foot or a square foot kind of thing. I would probably have to get with a supplier on the VRF and find out what it's going to take a little bit of time. I got to find out what his cost would be for a cabinet kind of device, cabinet ventilator, a unit ventilator and a cabinet. And he's going to have to help me figure out how big the system's got to be to do it. A heat pump, water source heat pump, I have to confirm the cost of the unit ventilator on that as well. It's been a while since we've used that. And I mean, it's gonna take a couple weeks to do it, but we'd have to get some supplier estimates and then put some labor to it. And then I may ask an MSD or somebody to review it with me, so that, I've got a contractor who's doing work currently up in that area, who knows what costs are, who would, perhaps support my number. So you're getting a realistic number.
Okay, and will that include the potential changes it would have on the operating costs? How much we would consume in utilities and electricity? And
I
with
could
that-
probably do a swag on that. It would be, that would be a little, to be precise would be difficult, but I could probably give you an estimate. I could do the best I can.
Mhm.
I can tell you, since you don't sub-meter everything on the gas, that would be easy to determine, right? That's not a problem. On the electric, since there's not a bunch of sub-metering, it would be hard for me to say, this piece of equipment is consuming this much. I can look at the unit and look at the voltage and the maximum amp draw and draw some conclusions and do the math based on that. But to know precisely how much a unit's consuming, I have to put a meter on it and run it for a month, and then determine, that'll tell me precisely how much that unit.
I think a range might be useful here to know,
Okay.
If this replacement is going to increase our utilities or our operating costs, or is it going to decrease it? Is it going to free up some electrical capacity? This kind of.
On the lights, that would be much easier to do because we can calculate the wattage in each light fixture. It exists today, as well as what an LED light fixture would. And then the question is how often, the lights on all day, all night? They're probably not, right? Teachers turn the lights off, or janitorial.
Janitors
lights
turn
off.
them off when they're done cleaning the rooms.
Yeah, so we can pretty accurately predict how much the lights are on, and we could come very close to giving you an estimate on that.
Mike, I'm assuming that you're working with Mike Richley, and I'm under the impression that we're going to be getting some approximate numbers from your two efforts at the next meeting. Is it safe to
That's
assume?
true. That's true.
Is it safe to assume that your mechanical efforts are going to give us numbers for like replacements? For example, the HVAC, you're just talking about rooftop units, right?
Correct.
Okay.
What Mike and I've discussed and I've been working on and discussed in details, Mike's richly is providing two numbers. One is a kind of bare bones, like for like, replace what you have. And there's two exceptions to that. One is I was going to provide a price to air condition the I think the high school gym. Right? Is that the gym? The high school gym?
Yeah.
And just as a separate breakout, this is what that would cost. And I was going to provide a price to put some kind of air conditioning system, probably a VRF, because that's the easiest to estimate, for the classrooms in Mills Lawn that do not have air conditioning, that have the window units. So other than that, I was going to give you a specific price breakdown of bare bones with those two exceptions, and then a more deep renovation where we were going to go back with something different, whether that's hot water, chilled water, VRF everywhere, or some other solution. And it was also going to include a completely redone bathroom and the front addition and some of the other things that have been kicked around. And Mike's got that broken down pretty good in his estimate. And my number will include what you absolutely have to do from the structural guy's perspective is the bare bones, and then some of the other improvements over time that you would have to do. I mean, maybe that's a third piece that we can talk about in the meeting as well. There's everything on his list probably needs to be done. Very little of it needs to be done tomorrow. Most of
You're
his
talking about Tim, Tim's. Yeah.
But that was also one of the things that Mike asked me to do, is separate what absolutely has to be done and from what needs to be done in the next 5 years. Did you want Tim at the meeting next week?
I don't know for sure, because I know Mike's going to be present. I'm trying to, the way I put it out a tentative agenda, which gave Mike an hour to present his draft drawings and costs, and then an hour for you. And if Tim was going to be there to talk in more detail, so I
Again,
don't know.
about Mike's estimates.
Yes. So
Okay.
I didn't know for sure whether it's worth his while to come, but there may be questions for him.
Yeah,
certainly.
I asked him, I invited him and asked him, he's trying to get his schedule worked out, but right now I don't know yet.
I would say that I don't necessarily need him to come, but I did put a question in the list that wasn't answered yet, which was about the state of a patio on the kindergarten exit at Mills Lawn, which is on north end.
Which
It's on the it was on the document. You've answered most of the questions, but some of them were left out. It's at the bottom of page 1 now. There is a concrete patio that is on the kindergarten exit right now, and the slab is completely broken down. There are some trip hazards there. It's not quite safe to cross there. It's definitely not accessible. And I was hoping to get this included in the scope of work that would be that would have to be addressed, and to know the cost of it.
Okay.
And I see some other THP questions there that haven't been answered yet. So if it can be answered, it would be great.
Okay. I see the question now.
If it's
David,
just
were you
metal, it could be slab jacked pretty quickly. I mean, they do that morning. Is it just uneven, Dorothy?
It's cracked.
It's cracked and it's uneven. You have more than an inch gap or inch difference between some part of a slab and
The whole
others.
slab outside the building needs to be replaced.
Yeah,
Needs
it
to be
needs to be
replaced.
jackhammered out and just redone.
Yeah. Scott, you've been totally quiet. Did you have anything you wanted to say or questions, comments?
Nope. I think we've got plenty of expertise in this area. I don't really have anything to contribute, I'm afraid.
we're
I feel
almost to
sometimes.
5:30. What? What'd
So
you
I
Can I
say?
just ask you, Mike, before you go, on the gym, for the
Yeah.
air conditioning on the gymnasium, it would probably help and make it where we wouldn't need to run the air conditioning all the time if there were really good fans in there. Those new modern ones with the big 8, 9, 10-foot blades on them that really push down some serious air.
They do. They work very well. They do.
And,
They
you
work
know,
in big
those, even
hangars.
with, yeah,
Are you talking about
And-
low speed, high volume fan?
Yeah, that's what he's talking about. Big ass fans.
Big
Yeah.
ass fan.
yeah.
Low speed, high volume. Big ass is a brand.
I know.
Yes. Okay. But yeah, there's several companies that make them low speed, high volume, and they do move quite a bit of air, and it does help. That is true.
That
Is it
would help push the
compatible
air
with
conditioning
sports?
back down.
They're in the gyms in the wellness center, if you want to see what they are.
No, but I mean, is it compatible with active basketball games and athletic games?
Well, when I installed the fans that are there, which are the regular ceiling fans, I had to put cages on them, more for volleyball for one thing. Basketball is not an issue. Volleyball was an issue, and the other issue is kids trying to hit them,
Yeah.
which happen all the
balls.
time. So it's the nature of a school building.
Yeah, well, we're at 5:31.
Okay.
Any last comments? Thanks.
No, I think this
for-
has been very helpful, actually.
Yeah, I do too. I really appreciate everybody's detailed thoughts on all the different systems, et cetera. And thank you, Michael Murdoch, for your time. We
No
really
problem.
appreciate it.
No
Thank you,
problem.
Mike.
Happy
Thanks,
to
Mike.
help, team. All right.
Thank you.
Thank you.
All right.
Thank you.
Oh,
Bye-bye.
Bye-bye.
see ya. I need to do something with this, don't I?